Dear guests, it is a great honor to welcome you to session 3 of AWARE and SHARE event, Automated Flying or Driving. How do we move in the future? Our session, Automated Driving, is still an utopian dream. We'll explore the development of technologies, cities, and society towards autonomous vehicles. My name is Wilson Bricio, and I will support you through this session. So let's then start with our first speaker of the day, Professor Werner Huber. Professor Werner Huber is professor for integral safety and its test methods at the Ingolstadt University of Technology since July 2016. He received his doctorate at the Technical University of Munich in the field of traffic engineering. In 1996, he joined the BMW Group, where he took over responsibility for the development of automated driving in 2012. At THI, Professor Huber heads a 12-member research group dealing with development, testing, and validation of automated driving functions in real and virtual world. Since July 2020, Professor Huber has been head of Charisma Institute of Automated Driving. So Professor Huber, now you have 15 minutes to make your presentation. Please.
Thank you, Wilson, for that very kind introduction. I just want to share my screen with you. And okay, do everybody see my screen? Is it okay?
Yes.
Yes.
From my point.
Okay, very good. So we can start. Yeah, thank you very much again. I'm Werner Huber, and I want to give you some critical reflections to automated driving. Is it a vision or will it become reality once? We will see, and maybe we will have some things to discuss in 15 minutes when I've finished my presentation. First of all, I want to introduce the Charisma Center in Ingolstadt at the Technical University of Applied Sciences. I'm working in this building. It's a building with a lot of laboratories, a big hall inside, a so-called indoor hall where we can have some testing of cars. We have a facility for rain. We have a facility for fog, where we can stress the sensors and the cars when they are running through a traffic situation. We divided Charisma into three different into three different institutes. One of them is the Institute of Automated Driving. We call it CIAT. Developing, testing, validating automated driving functions. But also, beside that more technical oriented things, we are also dealing with the evaluation of user experience, usability, questions of trust of automated driving. How can passengers, or how will passengers of a car deal with situations? How can takeover take place? And all this stuff. And also in the end, we have a specialist for artificial intelligence in terms of interpretable machine learning. The guys which are helping in doing that stuff is beside me, Mr. Professor Boch, Professor Gaul, and Professor Rina. Three of us are former, from the automobile industry, and Professor Andreas Rina is an expert in human factors. That's what our, let me say, our complete stuff is, and we have around 40 colleagues which are working with us on these questions of safe automated driving. Let me start with the levels, just to repeat it. Maybe some of you will know about, but to be on the same level, everybody, I want to introduce the different levels of automation. What does automation mean? Generally, and in the car, automation is the degree or the percentage of driving tasks which is overtaken by an automatic system. That means level 0 is no help by an automatic assistance system except some information. The driver gets into for his own decisions. Then level 1 is the assistance, driver assistance systems, where the longitudinal or the lateral control is taken over by the car. For example, an adaptive cruise control system, the braking and accelerating, keeping the distance to the car in front is taken over by a system, but the driver has to steer the car. This is a typical assistance system which leaves the driving task mainly by the driver and takes over only a small percentage of the driving task. A little different situation is the level 2, which is partial automation. Here, the longitudinal and the lateral control is taken over by the driver, by the system, and the driver has to keep attention to the traffic. This is not very fair, since all the physical activities are done by the car, taken over by the car, and the driver has to monitor the situation. So the mental workload is still left by the driver, but the physical workload is taken over by the car, and this might cause some problems in taking over those driving tasks back from the system when it's necessary. But all these the systems are now regulated by law and introduced into the market. Since the early 90s, assistance systems came onto the market very broadly, and then partial automation system like traffic jam assistance or a combined longitudinal and lateral control steering assist together with the adaptive cruise control is now available. I want to give you 2 short videos which will show how now driver assistance systems will prepare the way towards automated driving or higher levels of automated driving. Here shown with 2 BMW small videos.
Driving Assistant Plus. It's your personal co-pilot. This package hosts a number of new functions and is a big step forward on the road to automated driving. A system that already features a high level of automation is BMW's Steering and Lane Control Assistant. Now it uses smooth and comfort-enhanced steering intervention to help you stay within the current lane. This is perfect, especially on monotonous driving situations on highways, since it helps and offers more convenience and comfort while driving. Now let's focus on another interesting feature of the Driving Assistant Plus package, the Lane Change Assistant. Now it offers enhanced steering assistance when changing lanes. When the Steering and Lane Control Assistant is activated, just keep the direction indicator pressed halfway. The sensors of your BMW will then detect if there's a free spot in the desired lane, and if so, the system will automatically support your lane change maneuver. Pretty impressive, but have you heard of BMW's Evasion Aid? Now, if a swift lane change is required, the Evasion Aid supports the necessary evasive steering action. To avoid an imminent collision, it preconditions your braking system, supports your steering action, and also focuses on maximizing vehicle stability.
So that's a few examples of how driver assistance systems are now developed on more sophisticated. Especially the active lane change is very interesting, since the car is taken over a complete lane change and overtaking maneuver. However, it is monitored by the driver, and that means that car manufacturers are now starting those kind of traffic maneuvers to be automated in the car and supervised by the driver. That means they can learn, the drivers can learn, how does the system work, how does it function, and this is, on our opinion, the preparation of higher automated driving. But in the first step, it's monitored by the driver. Another interesting, from the technological point of view, is this remote control parking.
Now, a number of sensors ensure that your BMW 7 Series can securely pull in and out of the parking space by automatically supervising braking, acceleration, and steering. Once settled in, there's no need to sit inside the car. The engine turns off automatically. Starting and killing the engine is of course done remotely with the display key.
Also very interesting functionality, since what do we see? The driver isn't anymore necessary to sit on the driver's seat. He is operating the car with a remote control in form of his key, and he is more or less moving the car with his finger into the garage. That means the car can be controlled from outside, which is a tremendous technological effort to do that. And then if you get back to the car in the morning, you have to wake up the car, you have to start the car with this key, and to get the car out of the garage. And this is also technologically a preparation of the future forward to higher automated driving. Let me then jump over this fence to level 3, level 4, and level 5 systems. You know, those higher degrees of automation are on everybody's lips. However, what does it mean? It means that the responsibility is transferred from the driver, which is our classical traffic law, now to the vehicle. So the machine has to take over the responsibility in specific situations, in specific use cases. In level 3, the driver must be aware to take in a specific time the driving tasks back. And then on higher automated levels like level 4 or level 5, where all situations in specific use cases, let me say a complete trip on the motorway, or those things like a robot taxi are fully operated without any driver on the roads. However, today's there is no serious car which has more than level 2 on public roads. Everything which is done with level 3 or level 4 or 5 system is under test. It's not everything is regulated by law, and it's really under research. OEMs now are publishing so-called level 2+ systems, which means more and more automation, but the responsibility and the monitoring is left by the driver, like it's done at present by Tesla, BMW, Audi. All they are launching Autobahn pilots or rural road pilots with a high level of automation, but leaving the responsibility by the driver. Even the Waymo robot taxi is working on that. It's a big test in Phoenix, in Arizona, where human security drivers are sitting in the cars, in the robot taxi, and supervising the functionality of the cars. But what are the reasons, or what could be the reasons that the introduction of those higher automated driving could fail? On the one hand, it's the technical challenge, which is a huge challenge, especially since
Professor
there is a
Huber,
fail.
sorry, may I remind you that you have now 3 minutes still, and then we have some time for questions.
That a fail operational architecture is necessary. That means the complete, how is it called, effect chain from the sensors via the environmental models to the driving function and to the motion control. Also the connectivity to the back end has to be on a safety level, which ensures that in case of any failure, the car gets into a safe state. Especially the validation and testing, which is named about 6.6 billion test kilometers, which are necessary to validate those technologies, might be possible not on the road. It might be possible maybe only in the simulation. On the next is the homologation and legislation problem, liability, standards. We are missing standards. What is the ethical questions? What is the metric which is relevant to be compared when a human or when society is producing accidents and when automated cars are producing accidents. And this homologation and certification in different countries might last a few more years. In Germany, I will just jump through that. The federal government created some prerequisites. A strategy was launched for automated and connected driving. Also, the traffic law in the meantime was revised. It's allowed to operate a level 3 car on the road. However, it's not clear what you're allowed to do while driving level 3. An ethics commission, very interesting measure was launched that which is discussing about human lives and how should cars operate. So to have some borders for the development from an ethical point of view. Also, there is a big some big projects through the complete automobile industry of Germany, which is dealing with validation and test, and also some test fields in roads, in cities, and on the autobahn, on the motorways, are launched to test this technology. And the third, and maybe the major hint for introducing those technology is the social and individual acceptance. On the one hand, are all those let me say wishes we have for the automated driving to reduce the accident, to have a comfortable trip, to have automated motorways with high capacities, to help elderly drivers or blind guys to go to the traffic, or to create complete new cities. Will that become reality, and will people accept that cars will take over the driving task completely? When we have a look at the hype cycle, this is one of my last slides. 10 years ago, the autonomous vehicles it was said from Gartner, which produced that hype cycle, how emerging technologies will evolve over the years. It was said that in about more than 10 years, the cars will be on the road. And when we see now, we are just here in this, we have passed the peak of expectations, and now we are just crashing into this trough of the disillusionment. And maybe still it's this triangle, which means there will be another 10 years to have a level 4 car on the road, and I think that it's not a too bad expectation. Implementation for those cars will be the portfolio of complexity and speed. That means it will start on the motorway with a traffic jam pilot, very low complex situation, up to 60 kilometers. Then more on private environment, parking houses, ports, some functionalities like valet parking, shuttle, teleoperated transport will come. This is a little higher complex, but it's also from a technical point of view not too complicated. Then motorway assistance with higher speeds, but only in one direction. And then in the city, those kind of shuttles or a robot taxi will be on highest complexity. And the most critical will be rural roads without real separation of opposite traffic and different laws and legislations, which will be more or less, in my opinion, the last which can be introduced. In the end, summary, level 2 systems are state of the art. Level 2+ systems will more or less show up in the next years more and more, but level 3 systems are still a few years away. Maybe An L3 congestion assistant is in homologation phase, maybe 2022, available on Europe motorways. L4, L5 is still tested in specific situations. And the three reasons that might delay the introduction will be: how can we master the safety issues in technology, especially in corner cases? Not 90%, 90.999%. Can we work out the legislation in a way that it's okay to operate a car without getting the risk that the car manufacturer can't pay for the accidents? And what's about the social and individual acceptance, especially due to costs and due to the promises of changing the world and the mobility in total? We will see. So I hope some questions we will have left based on that thought I gave to you. Thank you for your attention, and I hope it was just in time.
Thank you very much, Professor Huber. We don't have much time for questions right now, but we'll have at the end. But one question I would like to pose to you is, in terms of safety, what kind of improvements for traffic flow in big cities? We know that Latin America has big concentrations of very large mega cities in the world. And what could we expect from this technology?
Automated cars are constructed to avoid accidents imminently, you know, that it's more or less not allowed to produce an accident by automated driving. That means the car won't drive too fast in specific situations. Maybe in those situations it will be too slow for the passengers, but it will always be prepared for avoiding accidents. On the other hand, an automated car won't get tired, it won't fall asleep, it won't have some perception errors and some decision errors, since if it would have some of those errors, it never would be launched into a public traffic system. So
thank you very much, Professor Huber.
Will be very high if we reach the state of publishing them on public roads.
Thank you very much, Professor Huber. Very good presentation. And we'll have some more opportunities at the end to discuss a little bit more. But now I would like to kindly ask Professor Márcio Lobo Neto, which is professor graduated in electronic engineering at the University of São Paulo and has a PhD in computing by the University TU Darmstadt. And he's associated professor in the Department of Electronic Systems Engineering at the Escola Politecnica of USP and associate director for mobility at the international area of USP. Under his areas of expertise are technologies related to smart cities, urban mobility, besides autonomous vehicle. Professor Márcio Lobo Neto, could you please share with us your presentation now? You have 15 minutes.
Okay, sure. Thanks a lot for the kind introduction. I'm going to start sharing my screen and just confirm if you have it. Is that all right?
Yes.
Okay, fine.
Thank you.
So thanks again. So my speech is going to be a little bit more in the technological and theoretical aspects of autonomous driving. So first of all, I raise some questions. The reason why we are talking about this, probably because we are worried about a greater safety and efficiency in the cars. And this kind of technologies will bring us there. And then how can we achieve these goals? Through connectivity combined with autonomy in an embedded intelligent systems that we're going to be available or are already available in the cars, but not still full, as we just saw in the previous presentation. So one also important issue is how to combine in this transition period the non-autonomous and the autonomous vehicles that will be sharing the streets. So then I address some technical questions about these technologies. And at the end, I intend to discuss a little bit about when or how it's gonna happen. So there is a continuous evolution of technologies, and we know that the cities are gonna improve in many different ways, the technologies as well. So we need to have technologies that will be able to continue evolving and to give us the opportunity to cross the paradigms from non to autonomous driving conditions. So I also bring here a slide comparing the evolution of the situations that we have seen in the last 25 years. In the beginning of the 90s, there were already in Germany, and there was a PhD student at that time, some experiences, for instance, from Mercedes-Benz with a self-driving car, which was able to drive in the German autobahns, even though there was no GPS, but just cameras at that time. And these cars were able also to drive in the roads, and even in bad conditions, weather conditions, as we see, just using the cameras that were able to recognize the signs in the autobahns. 25 years later, now we have much better computing technology, sensing technology, so we have deep learning embedded in the car, making it available or possible for the car to take better and more complex decisions. We also have GPS, radar, much better cameras that allows for sure the systems to get better information about what is going on in the surrounding. Okay, but we still not there, as we also saw in the previous presentation. So there are many technologies that are still improving, but we are not really there. So one interesting subject is how to combine different concepts. So for one side, we could think about, do we intend or do we really want to drive or not? Is that something that I'm interested in or not? In opposition to that, am I allowed to drive or not? So how do we combine these decisions, if I intend to do, if the car allows me, depending on the situation, if it's dangerous or not? So it's also important because it's really behind the kind of autonomy that the vehicle must have. I take into consideration perhaps one of the worst scenarios for driving, which are the big cities. So the metropolitan areas, as in São Paulo, where I am right now. Okay, so in these large cities, so worldwide, there are many technologies that are evolving, and we are starting to use the term smart cities to address those. But in fact, when we are talking about this, we can have two different paradigms. On one side, we have the top-down concept that allow us to design the cities. It's an engineering concept, also based on standards. We try to decide and to define things in a top-down fashion. On the other side, the cities are normally organic, adaptive. They grow somehow. So this is the bottom-up, which is the opposite concept, and somehow we need to be able to combine both concepts. I also present here a slide from a study that we did for BMV a few years ago, comparing different large cities worldwide, and on top of that, addressing different figures from these cities in order to have a better view of how to develop assistant technologies for mobility, not just autonomous drive, but in a wider sense for mobility. And then in this study, we did, for instance, some analysis of how the city is itself, how are the people that lives in the cities. There are differences. It's natural that it would be so. And also, we were worried to get a better or deeper understanding about the data that is available concerning all these things. From the city perspective, the maps, the data, the traffic information, but also from the people, how people decide to move, which is more frequent and things like that. Okay, that was really a panorama that gave us later better conditions to design some other projects that I will address at the very end. So, smart cities is plural. There are many aspects that might be addressed, energy, security, but now our focus here is autonomous driving. So I'm gonna address this point with two main concepts. Autonomous driving, from my perspective, means being aware, the vehicle itself, and being able to follow facts and to take decisions. And in order to do that, there are two pillars. From one side is the connectivity, so the availability of data provided by sensors, by communication devices, normally the V2V, V2I, X2X in the general sense, all based on or supported by IoT on top of the 5G technology that's coming right now. On the other side, we have the autonomy concept, which means, from my perspective, the full-time responsibilities. So the ability to be able to be aware of what is going on and to take the right decisions. So I would also like to address two different concepts in how we could design these things. By one side, we could think about a tailored paradigm where we use local apps, special purpose design, considering that there are many differences among the metropolitan area. So there might be perhaps opportunities to design things that are really tailored for different situations. Okay. We also see nowadays that there are millions of apps, and many of these apps are really designed for very specific purposes. On the other side, there is the opposite concept, where we have the general paradigm using large software, global standards, and really a general purpose architecture that allows the smart cities really to be implemented, so to say. But even in this case, we need to consider the possibility of scenario transposition, meaning that something that has been developed in one side could be adapted to another side. So then addressing the concept of autonomy and connectivity. In this slide, I talk a little bit about how are both connected to each other, or how is their interdependency. It might be very strong, meaning that one would not live without the other, or very weak, meaning that they are really taken apart. In fact, what is necessary is to have something where we have a partial overlap, and I explain that. The idea is that the connectivity is really a very important support for the autonomy, but if it fails, the autonomy must be able to go on without the connectivity. So that's why I'm mixing both in the way that I present here in this slide. Okay, so then I'll go a little bit deeper in some main concepts from autonomy and from connectivity. In both cases, there might be the standalone and the shared concepts, and also for sensing and design. So then starting with sensing, so that is related to all kinds of sensors, the GPS, the cameras, the radars, and also in this first example or set of techniques, I'm mentioning sensors that are embedded in the vehicles and that would be then able to work in a standalone mode. But on top of that, we could also take the advantages of the IoT and all the communications that are available, the data exchange, and the sensing itself will be, or is already, perhaps partially, shared with other vehicles or even with the infrastructure provided by the city. The same kind of concept also applies for the decision taking. Now, there are some aspects of the decision taking that are really local to the vehicle, but it could be also better if some decisions could be taken by sharing or ideas, sharing decisions, okay? All of this is done through threads, processes that are running in parallel and for all the time sending and receiving information, okay? And this is just possible, the shared mode, because we are assuming that there is a good connectivity, the communication or sharing capacity from gathering, sensing and decision data, or for broadcasting, sensing and decision data, okay? So then now I go a little bit deeper in the concepts about autonomous driving requiring sensing and reasoning, but particularly reasoning. There are two strategies. The symbolic artificial intelligence, which is from principle deductive, built upon logic, and able to implement reasoning processes by one side, and by the other side, the deep learning, which nowadays is really very important, and a fashion technology, which is inductive, based on statistics, and works really very well with perception and recognition. So In both cases, we also need to consider that they might be, let's first of all perhaps consider ourselves when we are driving. There are part of the time that we are driving in the automatic mode. So we know already what to do. There is nothing really new coming, and it's really without full attention. For sure, we are aware of what is going on, but not really worried about something. But then there are some events that brings our attention and that makes us be really full worried or aware or what's going on. So the technologies from artificial intelligence perspective that applies to each of these two different kinds of situations are different. So the deep learning is really good for these automatic aspects, while the attention and reasoning performed by the artificial intelligence might be a kind of supportive in those cases that they are required. It's a little bit slower, but
you have 3 minutes now, Marcio. Sorry.
Okay, fine. Thanks. So what in fact I would like to propose as the title of the presentation is the possibility to consider cognitive assistance by cognitive agents or tools that we would be working together to support the driver in any situations, okay? We could also consider this as a kind of pilot and co-pilot, where all autonomous things would be more performed by the deep learning facilities, while the other would be called if necessary, okay? It would be a kind of extended reasoning in these personal assistance or cognitive agents. So the deductive approach is a classical artificial intelligence. It's in fact what the computer program performs as its designer. So our rules, our knowledge is put the computer, and the computer does exactly as we do. But there are really some limitations because we cannot foresee all kinds of situations. On the other side, the inductive approach is much more interesting because we let the machine learn by the fact that we are training these machines in a very huge number of different situations. Yeah? And as far as the machine went through all this huge set of conditions, it became able to understand all of them and then to apply the right decisions comparing those that were already taken beforehand. Okay, there are also some cons in this case because some surprise may arise and then the machine does not really know how to act. Just to discuss that, there is, for instance, perhaps a good choice would be combining both approaches. And I'm just showing this picture with two tigers in order to highlight this concept. The deep learning machines, after being deeply trained to recognize these animals, could recognize this tiger very well. But once we put some noise on top of it, and we have this other picture, which for us is indistinguishable, the machine has no chance to achieve that goal. Okay, the same machine that recognized this tiger could not be able to recognize this other tiger. And this is just an example that situations like this might happen in the traffic scenario when then the machine would be lost. So finally, I would like to address this point where we need to consider how we will transpose the technologies. We are right now in the non-autonomous or in the beginning of this transition. Perhaps in the future, we will be in the full autonomous mode, but in fact, I believe we will stay here in between. Nevertheless, independent of this, we need to cross these boundaries because we will have, for sure, non-autonomous and autonomous vehicles, and this makes things a little bit harder. Okay, and that's just to mention that we also have some projects developed in this area that was also developed in partnership with BMV in Brazil, and it was a kind of development for autonomous, no, not really autonomous, an intelligent assistant for the driver. Okay, it's a kind of Waze plus where we can infer, right? So we can really understand better what is the next future combinations. And here I present some pictures about how was the development of all these things. In fact, what we are addressing is that in cities there are many different situations, cases. these things are dynamic, and the systems need to be adapted to understand what is going on when it's going on in order to be successful. And that's what I had to tell you. And I just to finish it, I will mention that autonomous drive must be human-centric, and I mean it should be developed to improve human mobility with efficiency, safety, and comfort. Thank you.
Thank you very much, Professor Márcio Neto. We have a very interesting question here from, just a moment. Yeah. We have a very interesting question from Marcelo Gribela, but I will just pose this question at the end when we have all the three discussing. But now I would like to, because of the type of the question is a very general question, and I would like to focus on the presentation of Professor Mario Lobo Neto and ask him one thing related to, again, from Latin America, we suffer a lot from non-standardized streets, lanes, signs, and we still, of course, we'll have a good development in connectivity, let's hope, with 5G and so on. But what would you expect in terms of development for the region that does not have such level of, let's say, normalized and infrastructure? Does it mean that the autonomous vehicles in South America or in Latin America will have to be in other parts of the world, will have to be smarter than, let's say, in Europe and North America?
Yes, perhaps. But in fact, what I think is that it's interesting because technologies comes very fast, and sometimes the development of technologies in some countries that are not really full developed comes even faster. But nevertheless, I would say that if we consider the technology that must be really available in the infrastructure on the streets or even in other cars, my personal opinion is that that might take a little bit longer in Latin America, or at least in Brazil. But on the other side, to compensate that, we have the 5G technologies coming, and this will be, I believe, fully available. And at least in large metropolitan areas, it might be perhaps in the countryside a problem. But if we take into consideration the large metropolitan areas, I think that this kind of technology could be really the right ones to provide some kind of assistance in the connectivity side of my talk. Independently from that, what we need is to consider that these technologies will not come very fast. So I mean, not all cars will have these technologies embedded. So the really difficult point is to have the possibility, is how to have the possibility of having simultaneously autonomous or partial autonomous and fully non-autonomous cars in the same street.
Thank you very much. So now I'd like to move to Mr. Pablo Leiva from Chile, which is coordinator of the Diploma in Smart Cities and of the Faculty of Architecture and Urbanism of the University of Chile. In his professional life, he has worked as a business developer for non-conventional renewable energy companies and is founder of the startup Inspatial, that since 2018 offers innovation service to companies of the heading of so-called utilities or basic service, mainly electricity distribution, domestic gas, and sanitary services. Its specialty is the processing of satellite images and artificial intelligence with computer vision techniques. It has participated in a startup bootcamp process of autonomous vehicles in Chile organized by IDB, International Development Bank, and Chilean Transport Ministry. Please, Pablo, now to your presentation.
Thank you very much for your introduction, Wilson. Thank you. Let me 1 second to share my screen. It's a pleasure to be here with you and all of the people connected by Zoom and YouTube today. I would like to thank to AWARE for this opportunity, for invitation. Thank you. Today I'm going to talk about the Chilean smart city revolution that we call an autonomous driving in Chile. Yeah, when we are talking about the smart cities, we put sometimes in a ranking. In almost part of the world, we like to make rankings. It's a human behavior. But I think that there are different ways to classify some smart cities. But a ranking, it's a very good starting point, because you know to in the same index different components of smart cities. For instance, this is one of the most usual smart city ranking in Latin America. It's made by IESC Cities in Motion. In this case, most of the top of the cities in Latin American area is related with the quality of this city, the quality of life of this city. That is why it's possible to say that when you have a very good quality of life, you have a very projects related with the smart city. The smart city is directly is a correlational relationship with the quality of life. But today I'm going to talk what's happening in Chile, especially about the smart city. And in the case of Chile, when we are talking about the smart city, we are talking about electromobility and one case of autonomous vehicles. Specifically in the public transport, in a few years ago, since maybe 2010, more or less 10 years ago, the public transport is a fair case of the improvement for creating a smart city in the whole country. In this way, in the case of Santiago, the capital and the biggest city of the country, it's important to remark that the public transport by buses in the first time has been changing and improving every year. But although in the beginning it had many implementation problems and troubles, because it's so complex to modify the way that one city it's moving, but a lot of years ago. That is why, but today, 10 years ago, or maybe 13 years up today, we could say that the problem it's improving. Another case is it's another example that some monitoring network for the electrical distribution with some specific case with artificial intelligence processes. In this case, we create the last year by the funds by the Chilean government some pilot to identify some aerial debris that in the picture, hanging cables and poles in bad condition. Because in the Latin American context, you know that we have two aerial cables in the cities. And that is why to monitoring, you need a more faster system to capture. In this case, we use computer vision and artificial intelligence system to make this more faster that send some worker to taking notes. That is why today it's possible to say in the internal ranking to which cities is in the top in the country. In this case, and some project was developed by some universities, some research. In this case, Santiago is the first city, but the condition of the city and the clean condition and the safety cameras and some pilot of projects for different parts for private sector and the government sector, it's creating more cities. But in this point, I want to talk to two cities in the south Puerto Montt and Temuco. This is both cities has been developing system to fight against to atmospheric pollution. That is why the quality of life is related with smart cities. Okay, talking about electromobility. In the public transport, Chile is the second country in the world after China with the most electrical buses on the street. By the end of this year, the authorities are talking about more than 1,000 electrical buses circulating in the city. It's this is a project between the private sector, that's who is the owner of the buses, and the same time with the government authorities. They are pushing to change by the middle of the century the complete buses by electrical buses. That is why the city is changing, because Santiago is very atmospheric, has a huge trouble with atmospheric pollution. But if you change the buses and then you are changing the cars, it's possible to see a more cleaner city. But this is a very good question for the context, for the Latin American context. But what happened with the smart city? It's for everyone. This is a picture that shows a very interesting case, because with the pandemic situation in the few months ago, it's very famous, this case, because the young lady, it's a university lady, that for capturing the internet connection, she needs to go to the roof to obtain because she lives in the rural areas, very far to the big cities. It's possible to see by technology that the previous speaker says, it's possible to see this advantage in the Latin American context. But what happened in the rural areas? What happened in the countryside areas? Okay, talking about the autonomous vehicle. In Chile, we have the first pilot. It's a project coordinated between the Chilean government and IDB, International Development Bank, the World Economic Forum, and the University of Chile, and the company Transfer, French company, to put on the street of the city one autonomous vehicle. This is a vehicle who is inside the park to connect two subway station. During this year, before the pandemic situation, on January, on March, the people has the possibility to take this shuttle and recover to inside the park for a few meters, 200 or 300 meters. But the idea was to develop and create an ecosystem between startups and private sector and the government to create, but the condition, but in the future, maybe in a few years, in a few years, it's possible to what happen if we create this kind of pilot in the private sector, for instance, in the mining sector, or in another part of the country. In this case, I want to show this video, if I have time, maybe 30 seconds. In this case, we participate in mobility challenges together with another 10 startups to improve different concepts. For our case, we concentrate in creating and proposing an integrated system between some LiDAR recognition with artificial intelligence recognition. That is why we have talked about to create an ecosystem. I think that, and I believe that it's completely possible to in our countries, in our area, in Latin America area, to see in a few years the possibility to autonomous cars in our street. We need to improve a lot of things on streets, starting by streets, but I think that it's completely possible. Wilson, thank you so much for your time. This is my last presentation, and vielen Dank. Thank you.
Thank you very much, Pablo, also for keeping the time.
Yeah.
So I would like to ask you a specific question related to what can you expect from the interaction of automated driving in a smart city environment? I can imagine that through connectivity and also the distribution of energy concepts and so on, you can develop also new business models. What would you expect from there?
I expect that our startup ecosystem we have in Latin America. I think that in the whole countries in Latin America, we have a very good knowledge, a very passionate entrepreneur. I think that it's completely possible to create different pilots that I show in my presentation, related with some companies inside or related with them. For instance, to create a system for inside the campus in the university. It's completely possible to make today, and a mining sector too, or maybe industry. I think that we have the knowledge, we have the entrepreneurs, and maybe the authorities need to approach, because the authorities, when they realize that it is completely possible to create this, the technology, it's open, the technology is very democratic. Our entrepreneurs, it's possible to read what happened with this kind of system. We have the contact with Europe and United States, Japan, wherever you want, but the authorities need to push forward this. This is my opinion, Wilson.
Thank you. Just another question regarding mass transportation. I know that and in Chile or in Santiago, we also have this bus corridors, like in Lima and in Brazil, in Curitiba mainly, and now spread out to other cities. Do you see any attempt or any, let's say, tendency to have autonomous buses in these corridors? Because this would be a kind of a controlled environment. Is there anything going on in Chile around that?
I think that we have to develop the environment to create this, because today I think that it's not there are not the conditions, because if we have the cameras, we have the process, but we need to put this on the street. We put to create a system, a strong system that coordinates what happened with the on the street, what happened with the buses. But I think that today we have to good attempt, but we have to develop this. It's not because you know, in this case we had a very Bogota too in Colombia. We have a very big cities. We have to very problems every day, and to think that to put autonomous bus. But I think that first we need to put some experience, like a pilot, and then to put on the street. I think that we need more time to do this.
Thank you very much, Pablo. So now I would like to address a question from Marcelo Griebler to all the three of you, and I would expect you to comment on that. And his question, I guess everybody could read it, but I just would like to stress the point that the implementation of autonomous vehicle from one side can be seen as a kind of a job killer for certain activities, like you don't need drivers for certain services and things like that. And what do you think would be the impact in our society in relation, not only, so let's expand a little bit the concept of just the jobs, which are very important, but what else do you think would be impacted when in maybe 10, 20 years from now, autonomous drive is implemented in, let's say, a good part of our cities? Maybe Professor Huber would like to start with his main comments.
Sure, I can start, but it's my personal opinion. If some jobs will be replaced by autonomous cars like taxis, then I'm sure that we will have less taxi drivers and more robot cars that could become reality. On the other hand, if we replace the driver of trucks or buses by autonomous technology, maybe the role of the driver could change more into a more service-oriented guy who is helping people to get into the bus, or the truck driver could do some maybe administrative work and be more or less his own disposer. And so maybe not only jobs will be lost, also jobs become maybe a new role and a new understanding.
Oh, thank you. So you're not really concerned of a real negative impact on that, right?
Yeah, that I don't want to state that I'm not really concerned, but on the other hand, I think that maybe a society could replace a driver by a technology and an autonomous technology. But the question is, how many of the driving tasks really can be replaced by an autonomous system? And will there be a driver still, not a driver, but somebody who monitors the technology, be left in the car or in the bus or in the taxi? And then he can maybe he's not replaced. He might be replaced as a driver, but not be replaced as a service person who can help to make a better service to the passengers.
Thank you. And Professor Marcelo, what's your view? Mainly, if we consider South America, where we have some of the biggest, I guess, one of the biggest bus fleets in the world for cities, and the transportation of goods is pretty much sustained by commercial vehicles, and the drivers is always asked in the market. Do you have concerns about autonomous driving making a negative impact on that?
Yeah, so for sure I have concerns because the social aspects are very, very important. But we need to consider that these technologies are coming and that we need to survive. And survive means that we need to learn to deal with all these new technologies. And we are really facing big problems right now because almost everything we do with devices like our cell phones, okay, with computers and so we need to be able to prepare better these people. So education is the first word. I think that is important to be behind all these things, because we cannot avoid using more and more autonomous driving, and then for sure some drivers will lose their jobs, but they must then take other jobs, and for these new jobs they need to be better prepared. Perhaps we could also find this I totally agree with what Professor Werner mentioned. In nearby fields, perhaps monitoring all these situations, but that will be probably not the case for everyone. So they will need to find other jobs, and new jobs will appear as the normal development of the society. And right now, the problem, perhaps the biggest problem, is that these things are changing and will change even faster and faster. So it's how to prepare people in such a rapid speed.
Thank you. And Pablo, what's your view on that? Well, how would you comment this?
I am reading there on chat. I have a good question. What is being doing? Let me check this. What is being done to combine people that autonomous vehicles are trustful and advantages for society? This is a good question that I want to put on the table today, because I am very convinced that electric cars, electric buses, and electric transport make more cleaner cities in our cities, in our context. I am talking about the pollution. That is why, but today we know that the price for the private cars, for instance, they are very high. And that is why it's not possible. But this is a very good question for authorities. They are putting the real incentive to the people buy electrical or autonomous car instead of the cars by combustion, traditional combustion. That is why, first of all, electricity, and the second way, the step is very close to pass to electric mobility and autonomous. I think that our correlation is very close. I think that we need more push about the authorities and the government in our countries. I know that we have very necessity first, but if we need more safe cities, if we need more cleaner city, this is a very good example to create, is it in our context.
Thank you. So I have another question here from Marcus, and the question is divided in two parts. So it states in the beginning like this: in professor's point of view, what is or which are the most critical gap, perception, decision-making, mapping, legalization, etc., to be fulfilled to allow the use of self-driving cars level 3 or higher? This is the first question. So what is the main issue? Is it legal? Is it technical? Maybe Professor Marcio Loboneto could start.
Okay, so thanks. I think the legal comes as a consequence of the technology. So we are showing as engineers what might be the next generation of technologies, what is coming, as was also presented in the BMV video. And based on that, we are aware that we need to take care of the new legal aspects of all these things. From the technical aspect, that's more where I am involved, I would say that we need to take care, because as I mentioned, and one of the slides present that there are some cases where the computer will fail. Then until perhaps somewhere in the future, it will not be that way. But right now, we are still in this condition that probably we still need the driver to be there. If necessary, he takes control of the car. But for most automatic issues, this new generation of machines based on deep learning with good perception, good cameras, many sensors, will be perhaps even better than ourselves in the task of driving a car, because they are better aware of what is going on. And as far as nothing really extraordinary happens, they can do that very well. I would also mention that there are perhaps still two extreme situations. In the stop and go case, where we are in the traffic jam in Marginal here in São Paulo, for instance, very slowly, just driving and stopping, driving and stopping. It's better to let the car did it by its own, because it knows how to do that and there is no danger. The other side is the opposite, is in a freeway, when it can really drive fast and observe things. The very complicated case is in the complicated traffic that we deal normally, not right now due to the circumstances of this pandemic, but in normal days, in the rush hours, the situations are very complicated to let the car drive alone. So it's a combination of perception and decision taking, which is already well done by the deep learning technologies. But as I mentioned, I believe that we need to have some kind of co-pilot that would handle those extraordinary situations.
Thank you. Pablo, what are your thoughts on that?
I think that maybe in the academic sector, we need to show to the people, to the people at authorities, that this technology is completely it's not a futuristic way. It's completely it's completely possible to see in our streets. I need to maybe to combine to the authorities, to combine to the people, that this kind of technology is completely it's not in a movie. It's not completely far today, because who we are inside this kind of techniques, just smart cities or autonomous driving, we know that the technology is completely possible to share between, for instance, in our case, in AWARE to Latin America. It's completely possible. We share professors, students, knowledge that maybe we need to show to our people that this is not a far future. It's completely possible to show in a few years.
Thank you. Thank you very much. And maybe Professor Huber, maybe you could comment also on the second part of Marco's question, which is related to always the negative approach, which is giving to anything that happens in terms of autonomous driving. Everybody has heard about the accidents that the Tesla car had, about lately in a competition of robot cars, one car just started and drove directly into the wall. There's a lot of, let's say, all these negative aspects are being widespread very quickly. The question is, do you believe that is there anything we could do to make it, let's say, a better marketing, also of the positive side of what autonomous driving could give to us? Because nobody could make yet a balance to say, in which situation would we have less accidents and less deaths or less injuries, but we are already questioning every single problem that we have with autonomous systems. What's your impression on that, and what would you think would be the way that let's say the industry, I would say, I would call here industry, everybody, also the development centers and so on, how should we react to this?
First of all, I really regret those unlucky events happened with Tesla cars. Since it's not a problem of an autonomous car, it's a problem of a car which has an autopilot, and an autopilot is not an autonomous car. It's an assisted car. And an assisted car, and this is also in the manual of Tesla, especially written, that the driver has to monitor the system. He's not allowed to sleep, and he's not allowed to take a newspaper or anything else while operating the autopilot. The autopilot has, on my opinion, the problem that it's a very good system, but it's not a perfect system. And a very good system leads to a trust into automation, which cannot be fulfilled by the system almost in the end, you know? So you have 99% of positive use cases. And so the driver feels the car can do everything. And in the end, 1% the car fails. And for this 1%, the driver have to be aware to intervene and to control the vehicle. And this might be the problem of those very high sophisticated automated cars, which are not autonomous cars, since an autonomous car is not allowed to have such rest risks. And then I want that you put yourself into the shoes of a product developer at a car manufacturer. We have a product liability, and the product liability says that if you bring a product into the market which is failing, then you are responsible for the consequences. So no car manufacturer wants to take over that risk. And this is a reason why cars are so delayed on the market. Since in the end, if the car fails, then the company has to take over the responsibility and to take over the financial consequences. And as long the legal framework and the framework from the insurances isn't ambiguous, then those cars won't be sold as autonomous cars on level 3, 4, or 5. That is my opinion.
Thank you very much. So I believe we are coming to the end of our session, but you're still free to ask questions directly to our speakers via bilateral chat. We have 10 or 15 minutes more. They are available for you. You just need to go to the speaker with your mouse, select the option More, and you'll find the option Chat. Then you can contact the speaker directly, and he will try to answer your question. And we see here Marcus is thanking the professors for replying his question. And dear guests, it was really a pleasure to guide you through our session today. And if you'd like to recommend us to your friends and colleagues, please do so. You'll find also the recorded sessions on the website of our AWARE website, and have a look at aware.thi.de. You also find our contact if you are interested in getting in closer contact with our AWARE Center. But last but not least, please help us to improve our event and give us your evaluation in a short poll which is being put to you. So I would thank you very much if you could answer to that.
Wilson.
So what?
Yeah.
Yes.
Pablo here. Only to complement that, that Professor Huber says, I think that maybe a good way is to create an ecosystem with autonomous cars and autonomous shuttles, that the people and authorities aware that it's completely possible, it's safe, and we realize in the past of the time that, and then to put all the autonomous cars on our street, on our autobahn, yeah? Maybe to create this ecosystem, to create more, we discover maybe a very clever ideas to improve this, and then in a second step or third step, to put cars on the autonomous car on the street. Maybe to create this firstly to create this ecosystem, maybe could be a very good way to to push the autonomous cars in our region, in our countries.
Sure, and I think that also with our relationship with AWARE and all the exchange and partnerships we're doing, we could more and more put this in evidence and try to structure more and more actions in order to analyze the needs and also analyze the possibilities. And I'm sure that we can have the support of DHI and Charisma on that, and of course AWARE has that objective. So I think we should do more for it and look for more cooperation on that area. But I think the platform is fantastic, and it just depends on us now to participate and to give inputs. And but it's a great idea. We can do a lot of things together for sure. So I think we're through. Thank you very much all for joining us, and I hope to see you in the next sessions. Thank you, Anne-Sophie, and your team for the great organization. Professor Huber, Professor, for your availability and for your fantastic contributions. I'm sure that everybody is much richer after leaving this session than before. And thank you very much, and also for having the patience to listen to me. Thank you.
Thank you, Wilson. Also from my side, did a very good job. Thank you very much, and all the other professors. Thank you, Pablo. Thank you, Marcio. It was a great pleasure to be in that session with you.
Thank you.
I also would like to thank all my colleagues, and especially the colleagues and colleagues from Ingolstadt. Thank you very much for the opportunity.
Thank you
to everyone to make possible this. Thank you.
Okay. Bye-bye.
Bye-bye, everyone.
Bye-bye. Thank you.
Thank you.